Message queue. How services talk. Hi, I'm Nikita Bogomolov. I experienced in backend more than 7 years and for now work mostly on the Ruby language, and examples in my lecture will be also on Ruby. If you want to discuss something or ask questions, you can contact me in my social networks, Telegram preferred. I'm friendly and open to new people. So let's start from question, why queues? Why you need to know about it? The most powerful thing of queues, this is async interaction between your distributed services. Second thing is delivery guarantee. All your data will absolutely deliver it to consumer. Handling at least once. This is also about delivery and quality of delivery. Message log. We can store all communication history in database and open it when we need it. And my favorite feature, we don't think about consumers, we just send messages into the space and hope that somebody will receive it. What software we can use for it? They called message brokers, and there are not only two solutions, but I will tell the most popular, Kafka and RabbitMQ. Kafka was created to work with big data, and Kafka works with batch messages with delay. So when you're receiving your batches, you have delay. Kafka waiting until the batch will be ready for receiving. Rabbit was created to work with small, fast events to notify your services about something that happens in your system. So it's fast and furious, it hasn't store. In Ruby for Kafka we have a low-level API gem Ruby Kafka, and based on it frameworks Waterdrop, Phobos and Kafka. For Rabbit we have kind of monopoly. It's low-level API IMQP and IMQ protocol gems and a bunny client. It's official client with good documentation. So Kafka and Phobos also have a good documentation and powerful functionality. Let's go to code. These three examples about Kafka sending messages. First is using Ruby Kafka. It's pretty simple. We just creating the client and deliver message hi to topic greetings. Second and third do the same, but using the producer instance. Here, how we send messages through Bunny. We need to create connection, we need to start it, we need to create channel, define the queue, and publish message hi to this queue. Also, we don't forget to close connection. This is how we consume messages in Kafka, using Ruby Kafka, the simplest example. So we just iterate all messages in topic greetings, and we can handle it inside the block. With Bunny, we again have to create channel, define the queue, and subscribe to this queue for receiving messages one by one. Okay, cool. Now we know how to send and receive messages. Let's split monolith into microservices. But not so simple. Give me a chance to tell you more about some difficulties. Broker doesn't responsible for processing only delivery. As you see, method deliver message in Kafka returns nil. That means that your producer doesn't know anything about result of handling, only delivery. Next important thing, impossibility of exactly one's delivery. This paradox, also known as two generals problem, and describes how it works in the real world. For better experience, brokers have acknowledged mechanisms. Consumers send to broker the delivery confirmation, and broker wouldn't send copies of messages. The important thing that your consumer worker can fail anytime, in the beginning, in the middle, or in the end of handling messages. One of solutions to prevent data inconsistency is idempotent code. This is example of non-idempotent code. If we will receive two same messages with user attributes, we will create it twice, or not create, or get active record not unique error. So this is bad for us. We make inconsistency in our database. Another example, we use find or create by method, and there are no problem to receive 1, 2, 3 or 10 the same messages. It creates user only once, and next time it don't make inconsistency in your database. Okay, let's talk about deployment, how we can deploy our brokers and use it on our server. First of all, you need main container, broker, Kafka or Rabbit. It's a black box and you can deploy it and use it in the simplest way. Second thing, it's producers and consumers. Through monitoring, we can upscale our consumers. For example, if we see many messages stuck in queue, we can upscale some consumers and quickly handle it. But this is headache of DevOps, not yours. If you're interested in details, I can recommend you this book. So what a developer headache? First of all, it's always a business logic. We should work with it the same way we work through HTTP. This is our main thing to do. All these are same things. Sometimes it could be really tricky and confusing. Interesting thing is a schema registry. It's kind of API contracts and describe how messages should look like. Explore it in more detail. You can see my favorite example of message structure. We have event name, we have created a timestamp. The popular instruments for schemas and serialization your messages is JSON schema, Apache Avro, and Google Protobuf. This is Avro and it looks pretty same as a JSON, and we have also a converter from JSON to Avro schemas. This could be very useful. This is example of Google protocol buffers. And why we need schema? Schema registry lives on separate server with access from producers and consumers instances. Your code can download the schema, validate the message before sending or before receiving. And if you need to update your schema and version of your code, you need to do these steps. First of all, you need to upload new version of schema to your registry. Now it has two versions, version 1 and version 2 of schema of your message. After that, you can update consumers. It should consume old and new message versions. So it could be 2 consumers or one with if-else clause. After that, we can update producers and produce message only version 2. And after that, we can disable old consumer, remove this code, and fully pass to version 2. And the last step, we can disable all consumer, remove old code, and use only version 2. Remember that producers doesn't receive any result from consumer, but we need it. How to solve it? I had a real example on my previous project, new user creation process. We need to create user, send it to profile service, and after creation, trigger another logic. To solve it, we can use pattern reply to. In documentation of RabbitMQ, you can find a full implementation for Bunny, so I wouldn't talk about it. I will tell you how to do it in Kafka. Remember our greeting message. Let's apply new schema knowledge on it. Mark event name with a sync flag, just for clearance. In a producer, we set reply to topic in the meta object. After handling, consumer can respond in this topic with some data. That's all what I want to tell you in this lecture. Thank you very much, and let's summarize. Async communication more complex, but it provides many ways to write your applications. Kafka and Rabbit are different, and choosing one of them, it's a very important architecture decision. Thanks for watching, subscribe on our channel and ask questions in comments.